Hi guys, so I'm out today for doctor's appointments. I want to go over this week's lab and then last Thursday's adventures in Google Expedition. So quickly, the sonar lab at Station 1. The big ideas I wanted you to understand from that reading and that video were, one, that 95% of the ocean is unexplored. I mean, we don't know what's out there. There is so much left to be discovered. And the biggest way that we can discover most of that quickly is by sonar. That allows us to create 3D imaging, and that 3D imaging, knowing that temperature, that depth, and what's going on there, lets us understand or at least hypothesize about what type of habitats might be there. If we know the habitat, based on the other areas of the ocean that we do know about, we can guess what types of life forms might be there. And then we're just really using this to hypothesize because we haven't found a means to easily explore all of the ocean floor. And with the average depth of the Earth being more than 2 miles deep, there are just too many monetary and scientific constraints to exploring that in a meaningful way. So we really have to hypothesize and conjecture. And sonar really helps us do that. What we do know is that chemosynthesis is a thing. That photosynthesis is not the only thing that drives life on this planet. And that's a huge breakthrough. Understand there are entire ecosystems that live around these hydrothermal vents, that live off of the chemical reactions which are created from the magma and the volcano and the gases exuding from the center of the Earth's core. That's shocking. And that is really important, that life can exist without the sun. We didn't know that before. And it exists in these areas, and there's thriving. There are so many cool things down there that we just didn't know were there. So that was the big idea from that first station. Station 2, so when you're looking at the wiser me, I really need to apologize for those of you in my Core 1 and Core 2. Yesterday I was working this out, and I had made some errors with that first section, so your grades are probably all sorts of wonky. Don't worry about it. I wanted you to get this kind of information. So the information is that wind causes currents, currents cause upwelling. Upwelling is that big idea that brings that nutrient-rich water that has all the dead stuff that we know on land. Dead stuff is fertilizer for new stuff, right? So in the ocean, that lives at the bottom of the ocean, which isn't helpful because things need photosynthesis to occur. They need sunlight. And so all that cold, nutrient-rich, dense water is at the bottom of the ocean, and there it shall stay, except wind. Wind comes through, moves those surface waters, pulls that cold, dense water up to the surface, and then kablowy, kabloom, we've got this combination of nutrient-rich water coming in this zone, this photic zone where sunlight can enter and photosynthesis can occur, and then phytoplankton. And then phytoplankton are those floating algae that serve as the basis of the food chain for the vast majority of ocean life. Chemosynthetic ecosystems are the exception, of course, but for the vast majority of oceanic life, and that's a really big deal. Second big idea I want you to get from there is ocean temperatures are more constant than air temperatures. If you thought about this, yes, that makes sense because air temperatures get well below freezing. The ocean obviously doesn't because it doesn't freeze over and we are not in fact snowball Earth yet. But this is important because it means that our coastal cities are always going to have more constant temperatures than our inland cities. Picture, Nebraska and Omaha where they get really, really cold. Picture the Dakotas where they can throw, cups of ice in the air and they are frozen before they hit the ground in the winter. And then it's 100 degrees in the summer, these huge, wide temperature ranges. And then you have that more temperate climate, that more consistent climate on our coast. So people like to live at the coast. So ocean temperatures actually regulate our global climate because oceans are less likely to change temperature. And there's that video on how that has to do with specific heat and heat capacity. That's a pretty higher order thinking concept. It's kind of difficult to understand at any level, and you'll study it more in high school, but I want to introduce you to that idea, that it takes more heat energy to change the temperature of water than it takes to change the temperature of that. The same amount of heat would raise the same amount of air, more degrees in temperature. So those are your big ideas from the sonar lab. Last is using all of this equipment. So we've got here our lab quest, and we've got our sonar. You have your box on the ground, Core 1. You need to have a folder on top of that box so your sonar doesn't go through the giant holes. Sorry about that. So you press play here on your graph. I'm going to do that so you can actually get a graph. And press play. Pull this up so it's out of the way. Make sure nothing's in your way. And ding, 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 ding. So then it's clicking. I know it's working. I move this. I don't have a partner, so life is much harder for me than it is for you. Ta-da! Alright, so I got to the end there. Now I look at my graph. I just went over the box. And this is where it gets interesting. Because here's my beginning. Right, you're looking at this red line right here. And if you click here, it tells you my position was 1.4. If I click here, where it goes down, it tells you my position was 1.2. So to blow that up, and those other variables are just me making a mistake. So it goes like this. And my stylus, my little pen here, tells me this says 1.4 meters, and this is 1.2 meters. The big idea is that that is actually measuring the distance from this device, which means I beg the question, which is further, the box or the floor? Everyone, the floor is further. So which of these is further? This is further, so that's the floor. This is your box. So your sketch should look something like that. And then your box and then your books should look something like box, books, right? So you've got floor, say at around 1.4. You've got your box at around 1.2. And say you've got this at 1.3. So this is box. And this is your stack of books, right? Because they're shorter. They're between these two heights. And then you're back to your floor again. And so that whole thing is just me seeing that you understand. So that's what your two graphs should look like, approximately, your sketches. So hopefully you can see that. Come over here to make sure you see it. Ta-da. All right. So sonar is the result of sound waves. Right here, I'm not looking for perfection. I'm looking that you are thinking about your results and making sure they make sense. Because that's what science is. So hopefully you understood it. If you didn't, that's what I wanted you thinking about. And you can go ahead and correct your answers. That's fine. Then, expedition to the Galapagos. So going back to last week where we did our 3D, fake 3D issue with the iPads. So first, the Galapagos. I really need you to understand that abiotic features in a marine ecosystem are your pH, your salinity, your depth, your pressure, your sunlight. If the only things you can name are rocks and sand and water, that's more like 6th grade level. I need you at 8th grade level. So pH, salinity, depth, pressure, those are the things that are going to determine what types of organisms live in that location. And so those are your abiotic features that are specific to marine ecosystems that you really need to understand. If you don't, write it, circle it, star it, whatever you need to do to make that happen. Furthermore, understanding those ocean zones. So as we move out from the ocean, right, you got your ocean floor. And your ocean floor is benthic. So you're going from here, from inland. Donk. So you've got your, this is your coast. Right, you got your intertidal, your shelf, your slope, your abyssal plain, you got your trench, and your hydrothermal vents, and then you've got your mountains, your mid-Atlantic ridges. All right, so that's your ocean. Whoop, and then does the same thing on the other side. Then your pelagic zone is the water. So benthic is all the stuff in black. Pelagic is all the stuff wonk. This is all the pelagic. All the water is pelagic. And you divide that pelagic into a couple different zones. I wish I had blue. I don't have it handy, so I'm just going to do this. You got your neritic, is the stuff that's over the shelf. That's all photic zone at 0 to 200 meters roughly deep. Then you've got your photic zone extends all the way out here. It's actually right here. It's going to be even with that. 0 to 200 meters is going to be your photic. This is anywhere that photosynthesis can occur. So this is also photic, but it's neritic because it stops where the slope is. This is your aphotic. Photosynthesis is not happening here, and that's your twilight zone. I'm spelling that all wrong, but twilight. And then you've got your abyss. Pitch black, total darkness. That's where all the weirdo organisms live. So understanding that benthic organisms are the things that crawl around on the bottom. And those would be different creatures depending on where you are. But benthic can mean here where your toes are touching the sand. It can also mean at the bottom of Challenger Deep. So benthic does not always mean deep. Last, corals are animals, and they're sensitive to change, and they're valuable habitats. They're not plants. Last but not least, acidification. So humans add carbon dioxide to the atmosphere by burning fossil fuels. Key. Carbon dioxide is dissolved in the ocean by wave action, just like dissolved oxygen. So that ocean waves are interacting with the atmosphere, and it dissolves stuff because water is a universal solvent. As such, the oceans become reservoirs, meaning they are containers for the world's carbon dioxide. They just soak all that carbon dioxide up. They have a whole lot of it. And then what happens is your water actually chemically reacts with the carbon dioxide to make carbonic acid. So you've got your H2O plus your CO2 from the atmosphere yields H2CO3, your carbonic acid. This acid lowers your pH, because remember your pH scale goes from 14, 0 with 7 at neutral, and all these things are acids, and these ones are base. You don't want this or this. The extremes are bad. pH you want right in the center. It's your Goldilocks. So what does this mean? Biodiversity is your friend. Biodiversity means you got a healthy ecosystem. It means you got lots of different types of things. Life, biodiversity means variety. The greater variety of life, the more stable your ecosystem is going to help your food chain. Because remember, if A eats B and B gets sick, then A dies. If that's the only thing A eats. But if A eats B and C and D and something happens to B, well, all right, you still got C and D to eat. Right? So, more stable food chain if you have more biodiversity. Acidification decreases biodiversity because, remember, pH is one of those abiotic factors which will help determine what organisms can live there. And so if you have a pH which is low, many organisms cannot live there. They cannot tolerate it. Most things can live around here. There are some stuff, remember, like that turf grass, that algae, that can tolerate and actually grows better in slightly acidic waters. But think about those zones. It was super, lots of fish and things in the normal, slightly less in zone 2. Zone 3, there was all those carbon dioxide bubbles from the naturally occurring volcanic vents, but there was nothing else. It was just that kind of gray turf algae everywhere because nothing was eating it, and it's thrived. Low biodiversity, unhealthy ecosystem, acidification was the cause. Those are your big ideas. Study up. You've got a benchmark on Thursday if you're in my Core 1 or Core 2. You've got a benchmark on Friday if you're in my Core 3 or Core 4. I will be here for studying Thursday morning, Thursday afternoon, and Friday morning if you would like to study. Your benchmark, as a reminder, will cover energy, so all the way back to those fossil fuels, all the way through water, fresh water, water quality, estuaries, and oceans. So there's a lot to study there. You want to be studying from page 27 to 45 in your portfolio. Page 27 to 45 in your portfolio. See you Friday. Well, Thursday. See ya. Bye-bye.